Hey folks, in this video, let's talk about an aspect of the AI in a global context and where India stands in that regard. We hear a lot in the news words like artificial intelligence, machine learning, large language models, data centers, and so on. Data centers are like the hardware part of this AI thing. LLMs, we can say, are like the software part. In this video, we'll talk about the hardware part, that is, data centers. Now, data centers are not only used to support AI functions. We all have photos, documents, videos, etc. on our smartphones and computers. In many cases, these items are stored or backed up in the cloud. That cloud is also a data center connected to our devices through internet. Big companies may use data centers to store company data and run their applications like CRM and ERP. Cryptocurrencies, online gaming, video streaming on applications such as Netflix or Prime Video are also made possible by these data centers. So, they have usage beyond just AI, but the current growth in the demand for data centers appears to be coming from the rising popularity and adoption of AI. So, how many or how much data center capacity does the world have? As of the end of 2024, there was over 120 gigawatts of total installed data center capacity globally. Now, the reason we measure data center capacity in megawatts or gigawatts is because data centers consume tremendous amount of power or electricity to run their CPUs or GPUs and to cool the entire thing. One data center may consume at a minimum 100 megawatts of electricity, enough to power over 80,000 American homes. Okay, back to the global map of installed data center capacity. Of 122 gigawatts of total global installed data center capacity, US takes the first spot, accounting for 44% of the total installed capacity. If you combine US and China, they make up almost 70%. European Union comes at the third spot. India has roughly 3.5 gigawatts of installed data center capacity, representing roughly 3% of the global total, which is in line with India's contribution to the global GDP. Now, look at the growth trajectory of the data centers. Numbers here somewhat differ because the data source used might be slightly different. It still tells a story directionally. After 2017, cloud computing and AI turbocharged the demand for data centers. You can see the exponential rise starting in 2017. Fun fact, globally, data centers are expected to consume over 450 terawatt hours of electricity in 2025, roughly 1.7% of the world's total electricity demand, and their power consumption is expected to almost double by 2030. Again, this is why data center capacity is measured in megawatts or gigawatts. One more way of looking at the data center capacity globally is the number of data centers by country. Based on this metric as well, the United States dominates, followed by Germany and the UK. An interesting observations, three nations with relatively tiny populations, Canada, Australia, and Netherlands, feature in top 10 despite having such small populations. India represents roughly 3% of the total data centers in the world. Let's zoom into India further. State of Maharashtra dominates in the share of India's data center capacity as far as the top 7 cities are concerned. Tamil Nadu follows in the second spot. In tier 2 or tier 3 cities, Andhra Pradesh seems to excel. I found it odd though that Karnataka's Bengaluru is not dominating on this map. Anyways, we see how India stands in the global context as far as data centers are concerned. India still is a relatively small player. One thing that one of the reports pointed out about China, though, stood out to me. Remember how China comes in second after the United States with almost 32 gigawatts of installed data center capacity? Public and private entities in China have invested billions in making this happen, but an estimated 80% of the new infrastructure stands unused. It gives me China's ghost town like vibe. But maybe China's central planners have a good reason to build out massive infrastructure for digital stuff. Who knows? Before I end this video, a quick word on quantum computing. Based on my limited understanding, like AI, quantum computing is also going to be a revolutionary technology. So, Traditional computers function in zeros and ones, that is, bits, but quantum computers operate on quantum bits or qubits. Qubits can be 0 or 1 or both at the same time, unlike traditional bits. It's confusing. But experts say this allows quantum computers to perform multiple calculations at the same time. And so, quantum computers can potentially solve certain problems that would take even the best supercomputers thousands of years in seconds or minutes. I'm talking about solving problems like designing a new drug or breaking an encryption. Quite exciting. But this technology is still at a very early and experimental stage, with many big tech firms like Amazon, Google, and Nvidia exploring this space. As a result, look who's leading here as well. This map shows the number of quantum computing startups by country. United States leads here again, followed by Canada and UK, but with a big margin. India is not shown on this map, but India also has around 13 core quantum computing startups. I hope you found this analysis interesting. I'll speak with you again next week. Until then, take care.